In this video, we're going to continue examining different applications involving rational numbers. These problems are going to be a little different than those from our last lesson because these are typically going to involve two steps to solve the problem. So each one's going to be a little different, and they may be a little difficult at first, but as you practice with these and kind of think through the situations, they definitely get a little bit easier. And if it helps to think about the context without the complicated rational numbers in there, I encourage you to do that first because it may help you figure out the steps that you need to solve the problem. So for our first question here, we have Mario, and he's buying some art supplies. So he wants altogether a paintbrush that costs $5.20, a set of paints that costs $5.15, and an easel that costs $16.30. So he wants to buy these three items. So $5.20, $5.15, and $16.30. He already has $6.90. So this is what he's already got in the bank, ready to go. We want to know how much more money does Mario need? So first, we should probably figure out what his total cost is going to be. So all of the things that he's planning on buying, we need to figure out how much he's going to need to buy that. So we have our $5.20 plus $5.15 for the paints, and another $16.30 for the easel. So if we add all that up, we're going to figure out how much money he's going to need altogether. So we take those three numbers, we combine them, and we're going to end up with $26.65. Now, we want to find out how much more does he need. So we're going to take our total, and we're going to take away what he already has. And then what's left is going to be the amount that he still needs to get. So we have that $26.65, and we're going to take away the $6.90 that he has, and that's going to tell us that he still needs to get $19.75 in order to purchase the rest of those items. So to recap that, we started by finding out our total cost, how much money everything was going to cost altogether. Then we took away the $6.90 that he already had to find out how much more money he needed to get in order to purchase those three items. All right, for this one, we have 30 students in math class, so this is probably going to be important. We know the total number of students in the class. And then we know that 1/5 of the class has their own cell phone. So that 1/5 is probably going to be important. Of this group of students, so this group is referring back to the cell phone group, half of them are allowed to use social media. We want to know how many of the students have a cell phone and can use social media. So first, I need to figure out how many of them have a cell phone because that's the first group I'm going to examine and take a closer look at. So we know that we have 30 students in the class, and 1/5 of that has cell phones. So another way to think about this is 1/5 of 30 students have a cell phone. And most often when we see the word of, that's going to mean multiplication. So we have 1/5 times 30. Now I can rewrite 30 as 30 over 1. And before I multiply those two fractions, I can do some cross-reducing. I have a common factor of 5 here, so if I divide 5 by 5 and I divide 30 by 5, this is going to become a 1, and 30 divided by 5 is 6. So we have 1 times 6 over 1, which is just 6. So now 1/5 of the class had their own cell phone, so 6 have cell phones. But we weren't just asked about who has cell phones. we were also told that half of the students with phones are allowed to use social media. So we want half of the cell phone group. So half of the cell phone group is going to be half of 6. Again, of is going to be multiply, so we have 1/2 times 6, and we can write that as 6 over 1. And again here, we can cross reduce. So we can divide by 2, divide by 2. 2 divided by 2 is 1, 6 divided by 2 is 3, and we get 1 times 3 is 3 over 1, or 3. So 3 students have cell phones and can use social media. All right, for our next question, we know that Jill had 3 full pans of brownies. Each pan made 10 brownies. Out of all of those brownies, Jill gave 3/8 of them to her friends. And we want to know how many did she give away. So I want you to try this one on your own. Go ahead and pause the video, see if you can figure out an answer, select it in the Edpuzzle, and then move on. Alright, so we're going to take a look at this one and see what we can do. So if she made 3 pans of 10 brownies each, first thing we need to do is figure out how many brownies we have all together. So again, of is going to mean multiply here, so we have 3 times 10, and you can think about this using common sense. In my classroom, I have 8 tables of 4 desks each. So to get the total number of desks, we'd multiply 8 times 4. Here we have 3 pans of 10 brownies, so we multiply, and we end up with 30 brownies all together. So that's how many she started off with. But then she gave 3/8 of them to her friends. So we're going to take 3/8 of 30, and we're going to multiply. So we have 3/8 times 30 over 1. And now I look for things that I can cross reduce along the diagonals. So 3 and 1 don't have any common factors. We can't reduce here. But 8 and 30 are both even. So I'm going to divide each of those by 2. And 8 divided by 2 is 4. And 30 divided by 2 is 15. So now we have 3 over 4 times 15 over 1. And I multiply horizontally, numerators to numerators, denominator to denominator, and we end up with 45 over 4. Now, we want to write this as a mixed number. So we say, okay, how many 4s go into 45? Well, 4 times 11 equals 44. So I have 11 wholes, and then I have 1/4 left over. So she gave away 11 and 1/4 brownie. So she must have cut something into pieces for her friends. So that's the answer to our question, 11 and 1/4. Technically 45 over 4 is the same thing, it's the correct answer, but it's better to write it as the mixed number here. Alright. Go ahead, pause the video, and try out our last question. Select your answer on the Edpuzzle, and then continue to see how you did. Alright, so Mia starts with 24 yards of ribbon. That's going to be an important piece. That's what she has to start off with. Then she gives 10 yards to her sister. So if she gives it away, it's taking away from what she has. So we're going to take away those 10 yards, and now she has 14 yards left over. She's working on a project that requires 2 1/4 yards of ribbon per project. And we want to know the greatest number of projects that she can complete with this ribbon. So I need to say, okay, how many times does 2 1/4 go into 14? How many lengths of 2 1/4 yards can I get out of my 14 yards left over? So I'm going to take my 14 and I'm going to divide it by 2 1/4 to see how many of those lengths I can get. Now remember that when we divide, we need to have improper fractions or just regular fractions, depending on when we start. So I'm going to have 14 over 1 divided by, and we convert this, so 4 times 2 plus 1 is 9 over 4. This is where we have to remember that when we divide two fractions, we have to use keep, change, flip. We keep the first fraction the same, and instead of dividing, we multiply by the reciprocal. So I'm going to go ahead and multiply directly across. 14 times 4 is 56, and 1 times 9 is 9. So now I want to turn this into a mixed number because I want to see what I've got left over. So we're going to take this number and see how many times does 9 go into 56. Well, 9 times 6 is 54. So we're going to have 6, and then we have 2/9 left over. But the problem wanted to know the greatest number of projects she could complete. So we're not necessarily going to say that she could complete 2/9 of a project, because then that project isn't complete. So this actually isn't going to be my final answer. But we're going to look at that 6 and 2/9, and the whole number here is going to be the total number of completed projects. Because we still have that 2/9 of a project left over, we can't quite get to 7, but we do have enough to finish out 6 projects.